Everyone, this is William Armstrong here with a YouTube video that came out May 6th, which is a Monday. Well, this is written by Dan Gooden at 3:35 p.m. Eastern time. Oh, Eastern time. It says here tunnel vision vulnerabilities existed since 2002 and may be already known to attackers. Novel attack against virtually all VPN apps neuters their entire purpose. Uh-oh. It says researchers have devised an attack against nearly all virtual private network applications that forces them to send and receive some or all traffic outside of the encrypted tunnel designed to protect it from snooping or tampering. Tunnel vision, as the researchers have named their attack, largely negates the entire purpose and selling point of VPNs, which is to encapsulate incoming and outgoing internet traffic in an encrypted tunnel and to cloak the user's IP address. The researchers believe it affects all VPN applications when they are connected to a hostile network and that there are no ways to prevent such attacks except when the user's VPN runs on Linux or Android. They also said their attack technique may have been possible since 2002 and may have already been discovered and used in the wild since then. Reading, dropping, or modifying VPN traffic. The effect of tunnel vision is the victim's traffic is now decloaked and being routed through the attacker directly, a video demonstration explained. The attacker can read, drop, or modify the leaked traffic, and the victim maintains a connection to both the VPN and the internet. The attack works by manipulating the DHCP server that allocates IP addresses to devices trying to connect to the local network. A setting known as option 121 allows the DHCP server to override default routing rules that send VPN traffic through a local IP address that initiates the encrypted tunnel. By using option 121 to route VPN traffic through the DHCP server, the attack diverts the data to the DHCP server itself, researchers from Leviathan Security explained. Our technique is to run a DHCP server on the same network as a targeted VPN user and also to set our DHCP configuration to use itself as a gateway. When the traffic hits our gateway, we use traffic forwarding rules on the DHCP server to pass traffic to a legitimate gateway while we snoop on it. Okay, I'm going to give you the TLDR, but DHCP servers are used to give like tablets, smartphones, game consoles, computers, routers. Routers have DHCP capability, therefore routers give computers, tablets, give laptops, tablets, smartphones, game consoles, smart TVs, any kind of device that connects to the internet. DHCP servers give the device an IP address on the local network, wireless or wired, either one. But it says here, we use DHCP option 121 to set a route in the VPN's user routing table. The route we set is arbitrary, and we can also set multiple routes if needed. By pushing routes that are more specific than a /0 CIDR range that most VPNs use, we can make routing rules that have largely a higher priority than the routes for the virtual interface the VPN creates. We can set the multiple /1 routes to recreate all the 0.0.0.0.0/0 all traffic rules set by most VPNs. Pushing a route also means that the network traffic will be sent over the same interface as the DHCP server instead of the virtual network interface. This is intended functionality that isn't clearly stated in the RFC. Therefore, for the routes you push, it is never encrypted by the VPN's virtual interface, but instead transmitted by the network interfaces talking to the DHCP server. As an attacker, we can select which IP addresses that go over the tunnel and which addresses go over the network interface talking to our DHCP server. We now have traffic being transmitted outside the VPN's encrypted tunnel. This technique can also be used against an already established VPN connection once a VPN user's host needs to renew a lease from our DHCP server. We can artificially create that scenario by setting a short lease time in the DHCP lease so the user updates their routing table more frequently. In addition, the VPN control channel is still intact because it already uses a physical interface for its communication. In our testing, the VPN always continued to report as connected, and the kill switch was never engaged to drop our VPN connection. The attack can most effectively be carried out by a person who has administrative control over the network and the target is connecting to. In that scenario, the attacker configures the DHCP server to use option 121. It's also possible for people who can't connect to the network as an unprivileged user to perform the attack by setting up their own rogue DHCP server. The attack allows some or all traffic to be routed through the unencrypted tunnel. In either case, the VPN application will report that all data is being sent through the protected connection. Any traffic that is diverted away from this tunnel will not be encrypted by the VPN, and the internet IP address viewable by the remote user will belong to the network the VPN user is connected to, rather than the one designated by the VPN app. Interestingly, Android is the only operating system that fully immunizes VPN apps from the attack because it doesn't implement option 121. That's great, but for all other OSs, there are no complete fixes. When apps run on Linux, there is a setting that minimizes the effects, but even then, the tunnel vision can be used to exploit the side channel that can be used to de-anonymize destination traffic and perform targeted denial of service attacks. Network firewalls can also be configured to deny inbound and outbound traffic to and from the physical interface. This remedy is problematic for two reasons. One, a VPN user connecting to an untrusted network has no ability to control the firewall, and two, it opens the same side channel present within the Linux mitigation. The most effective fixes are to run the VPN inside of a virtual machine whose network adapter isn't in bridge mode, or to connect the VPN to the internet through the Wi-Fi network of a cellular device. The research from Levithian security researchers Lizzie Moratti and Danny Krantz is available here. The TLDR of this is that VPN apps can instantaneously be killed. VPN stands for Virtual Private Network that routes your internet traffic through an encrypted tunnel from you to the internet, but this also has a vulnerability that's been around since 2002, a bad vulnerability that basically neuters VPN apps altogether. Like, it completely destroys the entire purpose. It's been around since 2002, and it already may be known to attackers. So this is William Armstrong signing out. See you next time. Bye bye.